All students are welcome to next chemistry lecture. Students, we seen in previous lecture rate of reaction and reactant concentration. How concentration of reactant affects the rate of reaction. In this we see rate law, what is the rate law, how it is written, and some examples based on it. Then in given lecture we see the next point from rate of reaction and reactant concentration, that is order of the reaction. So in this lecture or in this point we see what is order of reaction, how it is written from given chemical reaction, then some key points for writing of the order of reaction and examples based on order of the reaction. So let's start. First, what is order of reaction? So see on your screen, reaction AA plus BB, it gives CC plus DD, where capital A, B, C, D are reactant and products, and small a, B, C, D are their stoichiometric coefficients. If the rate of this reaction is given by rate is equal to K into A raised to X into B raised to Y as per the rate law, then what is order of the reaction? Simply order of the reaction is the summation of X and Y, that is sum X plus Y is termed as overall order of the reaction. So how it is defined? The overall order of the chemical reaction is given as the sum of powers of the concentration terms in the rate law expression. Simple order of reaction, it is the sum of the powers of the concentration which are raised, the terms in the given rate equation. This is the order of the reaction. So this concept can be explained on the basis of one example. We see two examples. First one, consider. First reaction, twice H2O2 in gas form, it gives, on decomposition it gives twice water liquid plus oxygen gas. Here experimentally determined rate law is rate is equal to, according to rate law equation, rate is equal to K, that is the rate constant, into concentration of H2O2. Here we see in this reaction the concentration or rate of reaction particularly depend on the concentration of hydrogen peroxide. So in the given equation, rate is equal to K into concentration of H2O2. So according to the definition or concept of order of reaction, this reaction is the first order reaction. Then we see next example. Second example of hydrogen gas plus I2 gas, it gives twice hydrogen iodide gas. Here we find experimentally the rate law equation for this reaction is rate is equal to K into concentration of hydrogen into concentration of iodine, that is I2. So according to rate law or the concept of order of the reaction is first order in hydrogen and iodine respectively, that as their concentration powers X and Y here is 1 so the order of reaction in terms of hydrogen and in terms of iodine is equal to 1, that is first order reaction. If we calculate the overall order of the reaction, we have to add the concentration terms for hydrogen and iodine, that is 1 here, X is equal to 1, Y is equal to 1, so total is equal to 2. So overall order of the reaction is second, that is this is the second order overall second order reaction, a simple order of the reaction. So we see some key points. We see some key points for writing or determine the overall order of the reaction. So first point is the order of the chemical reaction is experimentally determined. It is experimentally determined. Second one, the order can be integer or fractional. It is the values of order of, it may be integer or it may be fractional one. So consider example CH3CHO gas. On decomposition it gives methane gas, that is CH4 gas plus carbon monoxide gas. Here experimentally we find the rate law for the reaction was found to be the rate is equal to K into concentration of CH3CHO aldehyde raised to 3 by 2. Here the order of the reaction is 3 by 2. Here example of order of the reaction is of fraction. It is in fraction. Now we consider the second reaction. Here NO2 gas plus carbon monoxide gas, it gives NO gas plus CO2 gas. Here the order of reaction can be 0. How it is? It is possible the order of reaction is 0. Yes. So see, reaction NO2 plus CO, it gives NO plus CO2. The rate expression for this is rate equal to K, rate constant, into NO2, that is concentration of NO2 raised to 2. Here by observing the reaction and rate equation for this reaction, we say that the order of the reaction with respect to NO2 is 2 and with respect to carbon monoxide is 0. Here we say that the rate of reaction is independent of concentration of carbon monoxide. So the overall order, how it is calculated? We can add the sum of powers of concentration of both reactants, that is of NO2 is 2, of CO is 0, so 2 plus 0 is equal to 2. So the overall order of the reaction is 2. This is the third key point for the order of the reaction. Now fourth, only a few reactions of third order are known. Reactions with the order higher than 3 are scanty, that they are rarely formed. These are the some key points by find or determining the order of the reaction. Now we see some examples based on the order of the reaction. So simply, what is the order of the reaction? Simply it is the sum of the power of concentration of the given reactants. It is the sum of the power of concentration terms of the given reactants. So there are some key points while writing the order of the reaction. So see problem number 6.4, problem number 6.5 and problem number 6.6. You should solve the, try this and use your brain power. That problems are given in bracket on page number 124. We just see here problem number 6.4, problem number 6.5 and problem number 6.6. So students, see first problem 6.4. For the reaction twice NO gas plus twice H2 gas, it gives N2 nitrogen gas plus twice water H2O gas in vapor form. The rate law is, the rate equation for this reaction is given. Rate is equal to K into concentration of NO raised to 2 into concentration of hydrogen raised to 1. So what is the order with respect to NO and hydrogen? And here we calculate the order of the reaction with respect to concentration of NO and concentration of hydrogen. And second one, what is the overall order of the reaction? So first here by observing the rate equation for this reaction is rate is equal to K into concentration of NO raised to 2 into concentration of hydrogen. So by observing this equation, we say that the here the reaction is second order in terms of NO, concentration of NO, because the power of NO is 2 and it is first order in terms of hydrogen. So simple one. And how overall order of the reaction is calculated? We can add the power of both reactants, that is of NO and of hydrogen. Of NO it is equal to 2 and of H2 is equal to 1. So 2 plus 1 is equal to 3. So overall order of the reaction is 3, or it is the third order reaction. So simple problems. Now students, we move towards next problem, problem number 6.5. C. The rate of reaction A plus B is equal to P is 3.6 into 10 raised to minus 2 mole per cubic decimeter raised to 3 per second, where concentration of A is equal to 0.2 moles per cubic decimeter raised to 3 and of concentration of B is equal to 0.1 moles into cubic decimeter raised to minus 3. So here we have to calculate the rate constant K if the reaction is first order in A and the second order in B. So solution for this, see on your screen. Here the given data is the reaction is the first order in concentration of A and it is the second order in B. So according to rate law, we have to write the first rate equation for this reaction, that is rate is equal to rate constant K into concentration of A raised to 1 into concentration of B raised to 2. So K is equal to, we have to here calculate K, so K is equal to rate upon concentration of A into concentration of B raised to 2. Here given data, here it is given 3.6 into 10 raised to minus moles into cubic into decimeter into second inverse, or decimeter raised to minus 3. Here there are some mistakes in your book, so please correct it. Then concentration of A is equal to 0.2 mole per cubic decimeter raised to 3 and concentration of B 0.1 mole per cubic decimeter. Here we have to put the values of rate and also concentration of A, B. So we solve this, then we obtain the value of K is equal to 18 mole raised to minus 2 decimeter raised to minus 6 into second raised to minus 1. So simple problem on this. So student, we see the last problem, problem number 6.6. Here there are some mistakes in your book, so solve this problem or see carefully on your screen. So what is problem? Consider a reaction A plus B is equal to P. It gives P. If the concentration of A is doubled with concentration of B being constant, the rate of reaction it doubles, full stop. Second condition, if the concentration of A is tripled and concentration of B is doubled, the rate increases by factor 6. So what is the order of the reaction with respect to each reactor, that is A and B, and overall order of the reaction. So in this problem here we given two conditions. What is first condition? First condition is the if P increase the concentration of A is to 2, that is doubled, with keeping concentration of B constant, then the rate of reaction is double. This is the first condition. Now what is second condition? If the concentration of A is tripled and concentration of B is doubled, then the rate increases by a factor 6. So from these two conditions we have to calculate the powers of or concentration powers for given reactant, that is A and B, and some using mathematical operations. And then if we calculate the powers of given reactant separately, then we add these to calculate the overall order of the reaction. So see solution of this one, the rate law for the reaction, that is general rate law for this reaction, is rate is equal to rate constant K into concentration of A raised to X into concentration of B raised to Y. This is the first equation. Now see first condition. Concentration of A is doubled and concentration of B is constant. The rate doubles. So above equation becomes rate doubles, that is 2 into rate is equal to K. Concentration of A is doubled, that is we have to multiply concentration of A by 2. So K into concentration of 2A raised to X into concentration of B raised to Y. If we have to solve this one, we obtain the equation K into 2 raised to X. We have to separate the terms into concentration of A raised to X into concentration of B raised to Y. This is the second equation. So here, for obtaining the concentration term for A, we have to divide equation 2 by 1. We obtain 2 into rate upon rate. That is the first equation of left side. Is equal to K into concentration of 2A raised to X into concentration of B raised to Y upon right side of equation first, that is K into concentration of A raised to X into concentration of B raised to Y. That by solving this one, we obtain 2 is equal to 2 raised to X, that is powers on this same, as the bases are same. We have to use here mathematical laws. Base are same, their powers are same, so X is equal to 1. So we find out the order of the or power for the reactant A. Then we consider the second condition. If the concentration of A is tripled and the concentration of B is doubled, then the rate of reaction increases by a factor 6. So how we write this equation? So 6 into rate, the rate increases by a factor 6. So we have to multiply the rate by 6 is equal to K into, we have to increase the concentration of A is to 3 times, that is tripled. So it is multiplied by 3. So K is equal to concentration of 3A raised to X and concentration of 2B raised to Y. We have to separate these terms, and here we have to divide this equation by 1 as we done in previous mathematical operation. So we obtain the equation 6 into rate upon rate is equal to K into 3 raised to X into concentration of A raised to X into 2 raised to Y into concentration of B to Y upon K into concentration of X to concentration of B raised to Y. Same terms are gets cancelled. So on solving this one, we obtain on left side 6 is equal to 3 into 2 raised to Y, right side as X is equal to 1, so 3 raised to X. So divide or shift 3 on left side, 6 by 3 is equal to 2 is equal to 2 raised to Y. So base are same, then powers are same, so Y is equal to 1. So we obtain the separate powers for the reactants A and B. These are the order of the reaction with respect to each reactant, that is X is equal to 1, Y is equal to 1. So the reaction is first order in A. This is most important. You have to write the answer in details, that is last line, and also it is first order in B, and we have to calculate the overall order of the reaction. It is the sum of powers of the concentration of the reactant, that is A and B. X is equal to 1, Y is equal to 1, so 1 plus 1 is equal to 2. So overall order of the reaction is second, or it is the second order reaction. So students, in this lecture we see order of the reaction. So what is the order of the reaction, or simply concept of order of the reaction, how it is determined, or there are some key points for determination of order of the reaction. Then we see some problems depending on order of the reaction. So thank you all students for joining this lecture.